Hello, my name is Maxwell Warsaw, and this is my project for ECEN361. I built a custom mechanical keyboard. It is running on two Raspberry Pi Picos that are connected via UART, or connected by UART over this 3.5mm cable. It is essentially just a matrix of switches that have diodes to prevent ghosting and other artifacts. The way that it works is the Pico will cycle through each column, turning it on, supplying power, and then it will check every single row to see if any of them have power. And that's how it can detect a key switch or a key press. I have modified the Pico slightly so that way I can connect it via USB Type-C because it does not support Type-C out of the box. It has 3 test points on the back that I soldered up the Type-C breakout board to. And yeah, I had to model the base plate to support the Pico, and I had to figure out the software to get it to work. And as we can see, it does work. It takes a little bit to start up, but the LEDs turn on, indicating that it does work. I also have set up a macro to print quit for when I'm working in Python, and it does have FN keys, and it will Alt-Tab. So this is the code for the keyboard. Behind the scenes, I'm using a framework or library called KMK, and so what this does is it defines a KMK keyboard object. We set our pins for rows and columns. We tell it what diode orientation is. This all is for the split. I actually had to modify the code a little bit to support the Pico's UART. And then this is the custom string that just sends quit. It's right there. This is the key map, and you can see I've got 2 layers. One layer is the regular keyboard, and the other layer has the function keys, and all of these basically tell KMK to ignore that and to look at this key map for those keys. And then down here, we turn on the LED and start the keyboard. This is the original base plate for the keyboard. As you can see, there's nothing really in here, nowhere to put the Pico or the LED. There's also this big old hole that doesn't really fit with a Type-C port, and there's also no place to actually mount the breakout board that I used. The other thing is with this 3.5mm cutout, or the cutout for the 3.5mm jack, this bevel actually gets in the way of the 3.5mm jack. This is the base plate after I modified it. As you can see, there is a mounting point for the Pico. There's also a hole for a reset button, and a place to actually put the breakout board, as well as a nice little cutout for the Type-C cable, and a cutout of the chamfer so that way it doesn't get in the way of the 3.5mm jack, and a place to put the LED. And finally, this is the schematic for one side of the keyboard. Thank you so much for watching.